What we're looking to understand this morning is more about, like, I understand you're an expert in data infrastructure and reducing, like, let's say, the cost of warehousing data, and you're using artificial intelligence to detect data anomalies and also to screen for data quality. Um, I guess the first relevant question, if I may, if I may, is the idea of at what point does it become important or urgent to think about the data infrastructure? Is it only after you become something like Uber that you really need to be rigorous about thinking about data quality, or is it at a point maybe before that in the very initial start?
That's a highly debatable question. I mean, if you think about data quality, even big companies like Uber really don't have a way to actually um, test whether the data has an issue or not. It's usually reactive, where some data scientists or data analysts looking at reports says, "Oh, this doesn't make sense," and they will reach out to data engineers, and data engineer might say, "Oh, yes, we missed data." Or sometimes you have some alert mechanism saying basic level of data corruption, like duplicate detection, just counting unique rows.
Okay.
Those kind of things are available in, but they don't capture all kinds of error. I mean, just to give you example, um, one of the things that failed at Uber and caused a huge outage was the way they used to encode countries. So the country code for Asia or India actually changed from something, one string to another,
Okay.
and that caused a complete outage in the whole data pipeline because things were like hard coded.
Got it.
And so the in fact the problem happened is not even the outage as such, like nothing break, but the report started completely missing statistics on India, and this was discovered like after 3 or 4 days, and caused a huge issues. So I think it's always a good idea to think about data quality from the very beginning and the whole infrastructure. So I see two major problems with the data infrastructure. One is um, usually it's not easy to debug or test your scripts. For example, if specifically if you're using Hive as your ETL pipeline, like if you're using Hive to like transform data one process to another, then that particular Hive script is not easily testable. And so what I would recommend is, like, if you have a Hadoop kind of environment, really investing time into like building a PySpark, adopting PySpark as your ETL pipeline.
Wait, on that part, could I please ask for clarification again? You said on a Hadoop environment, a docking spice. Uh,
No, PySpark, Spark.
uh,
Databricks has this Spark, essentially using Spark.
oh, Spark. Okay, yeah, I've heard of this.
Yeah.
And these are essentially different data languages, right? Data science languages that we use to create the scripts and the mechanisms to sort of uh, implement
Move
data
the data
qualities.
permanently.
Got it. Got it. Okay.
So
Um, in that,
the
oh, go ahead, please.
I mean, the trade-off you have. So, for example, when if you're talking about data infrastructure,
Mhm.
what are the major components? One is you're constantly transforming your data from one thing to another, right? So you have raw data that is coming as logs in Kafka, and then from Kafka you're generating your model tables, and from model tables you're generating your aggregates and analytics tables, right? So how you do all these transformations? You have a lot of different options. One is Hive, another is using Pig, or usually people companies use Hive, but increasingly companies are adopting Spark,
Okay, got it.
and I think that is a great move using Spark.
And what sort of we're not quite there at like let's. I'm actually just curious actually to understand the scale of Uber. How many new entries per hour are appearing as like let's say log files? What is the data accumulation
Oh,
rate?
yeah. So um, I can give you estimate at a daily level. So on a daily, when the business was going pre-COVID, it was like a million records per day, million trips per day,
Wow.
and each trip generates almost like few kilobytes of data, I would say, because you're logging several things. I mean, not only on the mobile side, but you're also logging on the backend side, right?
Mm,
How the service request has gone through, like what are the different services got invoked, how the data, how this request flew through from a service to another, latency across services. So you're capturing so much information on the backend side, on the driver side. So you're capturing information on the driver side, on the client side, and
interesting.
on the driver side, you're also capturing GPS coordinates every few seconds.
Understood. Understood. And basically, this data is for certain purposes. I would imagine the front end data is to improve the user experience, and the back end is to essentially figure out the infrastructure and tune it so that it gains better efficiencies. And
Right.
I remember this at Airbnb as well. I was actually quite surprised that the production servers actually running Airbnb, the site and the mobile, were about three times less than the servers running like analytics and data collection and modeling. And I was really surprised. I thought actually there would be more serving guests than actually serving internal understanding of how guests and I guess the system is behaving. But is that pretty normal too as well on Uber side? Like there's actually more computational resources allocated for understanding what the data is rather than actually running the business services.
Um, that's true in some, actually, in many ways, yeah. Because, but in terms of computational costs, I'm thinking whether it's true or not. I mean, definitely you have a much bigger cluster for analytics. You and I think you're right. It's 3 to 4 times. Hmm, I'm trying to recall the numbers actually. 1,000, 30,000. So I will give you a ballpark estimate.
Sure. Oh,
The data infrastructure um, accounts for 30% of the 30 to 40% of the infrastructure cost.
wow. Okay.
Mm, this data infrastructure, what we are talking about, is purely offline analytics.
Got it.
So managing data, storing data, running ad hoc queries. So rest of the 60%, or like if you say 50, 50% out of that. No, so it's definitely not three times, unlike what you were saying in Airbnb. I
Okay.
would say it's a 50-50 split.
The 50-50 split. Okay. Interesting.
Yeah.
If if it's a okay, interesting. Um, and I'm actually kind of curious, sir, because I saw that you actually had a pretty interesting career. How did you end up specifically being in this part of the data science stack in data infrastructure?
I guess just because of interest and my skill set, I naturally gravitated towards that direction.
Got it. And before you worked at AT&T and T and also Netflix as well. And how much of that like because I remember when I was in the Bay Area, I went a lot to meetups back in 2013 actually. And Netflix was I remember every Netflix engineering event I went to, there was always or any Netflix speaker would always talk about this. They would talk about like sharding databases and and load balancing. And there was a really involved topic, I think, at Netflix because they have, I believe, a huge amount of data that they're moving through, and they're trying to optimize. And I remember they were also trying to move it off of AWS because the costs were getting a little bit high. So
No, it's the other way. They move from data center to AWS,
they did
100%.
it. Oh, sorry. Okay, my mistake. My misunderstanding there.
Uh,
And so I guess what are sort of like the I mean, this is probably way down the line for us, right? We hope to get to the level where we, need to really think about how we optimize our data storage. But at what sort of are I'm trying to anticipate what sort of our first step moves to make that okay. So we have the language that we choose to actually transform the data along each stage of the process. But are there any other good principles? Like I'll give you an example. Something we're doing. Too bad our CTO couldn't join us today. But something that we're doing right now is actually we're running analytics off of production data, and we had to speak with a data scientist from Airbnb who was also working on the luxury retreat side of the business. He said that we should never do that. But then eventually we kind of agreed that it would be okay to do it when you're a smaller company, but definitely
yeah.
not to do it when you're a bigger company. What are your thoughts on that? Like actually running analytics on production data. It seemed like a big sin from his perspective, but there was also some technical sort of how would I say there was some technical efficiencies from that.
So, when from technical efficiency, if you're a big company, definitely you don't want to increase your load on the production server,
Mhm.
right?
Got it.
For example, if I'm an analyst, I suddenly run 1,000 queries, or you have 1,000 analysts and all of them run the same query. What is the likelihood of your production server going down? And that can have a huge impact, right? Even if they all these are read queries,
Right.
but you don't want to sacrifice latency on the production server for production traffic.
Got it. Got it. Okay. All right.
So that is, but I think, and the other thing is, um, as an analyst, do you really need raw transaction tables, or you want to work on aggregates? And that can be another. So essentially, your production data usually has the raw transactions,
Mhm.
right? Whereas as an analyst, you might be pulling data from a lot of different places and creating really, and over time you build aggregate tables,
Mhm.
for example. So
Uh,
I would say, okay, that's not the biggest point is actually just, do you really want to affect your production traffic?
got it.
I
Got it.
mean, that is the biggest concern.
Understood.
So,
Understood. I think
in
I see why they made that trade off at this point because I mean, we're only at the size of a few hundred records a day at peak, right? So we're not quite at like where I think the production would be affected at this
yeah,
point. But
and it makes sense just to run directly. Although I would definitely recommend having a separate account when you're running analytics queries,
mhm,
which is basically has only read access
got it.
to avoid accidentally writing anything.
Okay. I'm actually kind of curious also, Mr. Agarwal, what was your proudest piece of work that you did at Uber or Netflix? I've read multiple blogs about engineering efficiency and actually how even to calculate the cost and using actually pretty cool. Like you're using like a sigmoid function to determine cost and also look for ways to reduce like the what do you take like let's say the most pride in like in terms of your work?
I think one of the project, the one you were referring, that is one of the very interesting project. I really love it. I mean, because it had a huge savings, and it's interesting. I mean, why it's interesting because there's a huge cost of maintaining a table, right? You spend on compute resources, you spend on cost, storage cost, And rarely we think about the utility of the table. And uh, this kind of the project that less is more addresses exactly that. And because of that, we were able to find tables that have a much lower utility
Hmm.
than the maintenance cost. And then based on that, we made actually decisions not to maintain those tables on Vertica, which is like a more analytic engine we use at Vertica, Uber.
Understood.
And it had a huge savings.
And that type of efficiency finding is actually that it seems like that's I don't know, for me it seems like really new because like normal most of the time I think this approach to data is like from a consumer mindset, okay, I'll just buy more drives, I'll buy more storage. But when you're dealing with like petabytes of data and you're dealing with also incoming more data coming in as records, it's almost like you're a financial engineer. You're thinking of like how to actually how to manage this asset in a way. Um, what what sort of goes on in your thought process of like how to well more now about how to build the team and create, let's say, the correct dynamics where you're discovering the right problems, where you're being able to delegate, where you're able to kind of get a bunch of people to think about this problem as a group.
I think one thing as a team and like as an individual, one thing we definitely start from the very early on is thinking about ROI. Ultimately, everything, if you have a way to convert everything to cost, that is the best thing you can do. Because if you can see where you're spending money, that automatically forces you to think about efficiency. So I mean, give you example. Simple. Let's say you have 10 petabyte of data, right? And every day you're getting another 1 petabyte of data. Or let's say you have 100 petabyte of data, and every 1 month you're getting another 1 petabyte of data,
Yep.
right? Do you really need, and let's say you have last 6 years of data, okay?
Yep.
Uh, do you really ever use your last 6 years of data,
Probably.
either in analytics? Probably not, right? Then does it make sense to keep that data in the same place where your recent data is stored?
Probably not.
So,
It's a caching mechanism.
huh?
This reminds me of caching from engineering. Like I remember like how a CPU has caches. Like it has a
Right.
cache.
L1, L2 cache.
Yeah, that's right. That's right.
Right.
Interesting.
So that's exactly, I mean, so one optimization that you can do is you store your most recent data in SSDs, because SSD enable to read the data much faster.
Yeah,
But you store your older data on metallic disk because the read time increases, but you're rarely reading that. And your metallic disks are much cheaper as compared to your SSDs.
that's right.
So you have those kind of mechanisms, and then you're effectively utilize. So eventually you're balancing your cost, you're reducing overall cost, but not you're at the same time you're not trading your computational speed because you're working on SSDs.
Okay, that part I understand immediately. I have a long time ago actually had a computer science background, and
Mhm.
and so I remember this concept of caching and storing like the things that you use frequently that you need quickly closer to the processor so that it has a
Right.
lower latency. I forgot that that actually applies to cloud computing as well, and I even remember I remember storing things on tape at a certain point to if it was going to go into an archive. Um, Fascinating, actually. This is really interesting. What sort of the other thought question that appeared in my mind was around. I had it at the moment, but I forgot to take a note. What sort of what sort of oh, I drew a blank there. Sorry. Let's go to Lilith actually for a moment. Maybe give us chance. Lewis, do you have any questions for Mr. Ritesh Agrawal here for uh, data or data infrastructure or uh, any thoughts there?
Thank you, sir. Actually, just now I'm listening because actually my background is not really data scientist, sir. I'm kind of understanding what is your, what is the point? That take the takes away. But maybe other question is not related to data production or something else around that, but maybe uh, uh, what? Oh, video is coming. What is actually we can how we can uh, actually I haven't formulated the question, sir.
Ah, that's fine.
Like,
Okay,
uh, give me some time to
okay.
thank
Yeah.
This is perfect then. Okay, hey, Vinny, welcome in. Good morning. How you doing, sir?
Hi, good morning.
So one thing
Hi,
that you
Agarwal.
asked about like principles for data engineering,
Hmm.
I think two mistakes that people often make when dealing with the data engineering or infrastructure is first thing, I think it's in general, non time zones and time dealing with time.
I've noticed that actually. Okay,
Yeah, so I think it's very important to make sure you're consistently changing all the time to UTC,
right.
and at the same time for your somewhere being able to convert that into a local time for client or the trips or whatever your product is.
Absolutely.
So I mean at Uber we generally convert both in local time,
Hmm.
keep all the things in local time as well as in UTC
Okay, everything too.
in
Absolutely
tables.
right. You're absolutely right. I know.
And
Oh, sorry to speak over you, Mr. Ritesh. Go ahead.
the other thing, so it seems right now you guys are not using Hadoop as a infrastructure.
Not at all.
So yeah, when if you're a stage where you have start using Hadoop for storing, um, oh okay, actually that makes sense. So um, thinking about how to partition your data is very important, especially when you get onto Hadoop because you don't have indexes and it's a huge computationally expensive if you don't have the right partitions. But now actually one thing I realize it might not be so important for you to have a separate database for analytics and for production. First of all, you don't have that much traffic.
Mhm.
Second is because you kind of your production data has the full historical data. It's not reaching to a point where you cannot store all this. So usually you have a separate analytics data because you cannot store in the production database all the historical data.
Got
So
it.
let's say if you have now if company like Uber which is operating for last 10 years and which has all the trip in millions of trips. You don't want to keep all that data in production server because first your indexes will become huge,
Hmm.
and second your query latencies will become very high.
Got it.
So, but that doesn't apply in your case at this point.
Got it. Okay. Yeah, we're below the threshold, I think, of
Yeah.
the necessity. All right, Mr. Agarwal, let me introduce Vidi. Vidi's on our team. He's a recent grad from UGM, one of the universities here, one of the best universities here in Indonesia. He comes on board as a data scientist, and he's actually working on he's actually thinking about some of the topics that we're talking about how to get the data more efficient. I'll let Vidi introduce himself.
Hello.
Hi, Mr. Ritesh.
Hello. Hi.
Nice to meet you. My name is Fidi, and I'm a data scientist in Bukit Vista. I am a graduate from commerce science. I have a bachelor degree in commerce science. And currently I'm trying to work on trying to start an AI initiative in Bukit Vista. And my thesis topic actually covers convolutional neural network
Oh wow.
and image processing and image classification. Thank you very
Oh,
much.
your skill set is in a lot of demand right now.
Yeah.
Definitely. Actually, maybe we can turn the question over to the AI part. Understand, uh, VD has been formative in sort of creating my intuition about understanding data science, and understand within data science there's sort of a hierarchy of how the data is built up. There's, I believe, data infrastructure, data analytics, and then there's AI and machine learning. But then in your particular case, I saw that you applied AI and machine learning back into data infrastructure so that you could clean data. It was related data quality, I recall in the paper.
Efficiency and quality.
Exactly. So in that regard, maybe you can talk a little bit. To me, this is a little bit funny. This is almost like using a different part of the hierarchy to address a different part of the hierarchy using data, artificial intelligence, and like I guess where I'm going is, how do you start creating the beginning of artificial intelligence? How do you start selecting the models, evaluating the models for accuracy, detecting if your forecasts are making sense, and going about that process? You mentioned that it was hard to be proactive because a lot of these errors in the infrastructure are only detected retroactively, right? But is there any part that the AI plays to alleviate that I don't know.
Uh, so when people talk about AI, I mean, for me, it's all machine learning.
Okay.
End of the day. So I usually don't differentiate between machine learning and AI. I mean, um, now about this hierarchy, yeah, you're true. You're right. There's data infrastructure. Then they call it the pyramid, data science pyramid, and the first level is actually logging the data, uh, because until you and then the second level is the data modeling, or actually sorry, so one is logging the data, because if don't log, you cannot really have the data. Once you have the logging the data, by logging the data itself doesn't mean the you can now do all the AI and ML thing. You have to first build the data models. By data model is you are essentially putting the data in a form that can be easily used, right? So
Yes.
you're joining with customer information, driver information, and enriching the data with a lot of other fields. And that is a data model. On top of that, and this is where, like, I would say bulk of the work goes initially, setting the foundations. Then the next thing you always want to do is a descriptive analytics. Essentially, once you have this is where dashboards become useful, or you should, once you have a data, for example, how many customers are visiting on your website on a day-to basis, how much is the earning on day-to-day basis. So you start building some trends and looking at what is the variance around each of the metric. So this is where descriptive happens. Now, once you start looking into descriptive analytics, it will show certain problems into your data, all right? And that leads to diagnostic analysis. Once you see why I'm observing this increasing trend, or why I'm observing this decreasing trend, or why I'm suddenly seeing spikes. So descriptive, so logging data, data transform, building data model, and descriptive, these are your foundations of the pyramid, and this is where most of the time goes. And then you do diagnostic. Once you have diagnostic, you have identified the problem. AI and ML should be used only after that, only if you think there's a problem that cannot be solved by rule based system or any simple solution. So I of my biggest concern is always, if you're using machine learning as the first solution,
Uh,
it should be the last solution you should be looking into, because over it's Building a machine learning model is not just one time activity, it's a huge cost to the company because you have to constantly train, you have to invest in building features, and there's a whole platform that you have to create just to sustain this model.
Got it. Okay. Um, to speak about why we think it's important, this is actually related to our revenue management at the moment. So currently, uh, nothing compared to Uber once again, but we have about 180 different properties that we manage, and we manage the pricing on these properties every day to optimize for tuning on the Airbnb algorithm. So we look at essentially the statistics on Airbnb to give us an understanding of how each particular property should be priced on daily, monthly, weekly, and also across time, across each season. So this type of work is absolutely exhausting to do, human wise, and it's actually inconsistent too. It's based a lot on each person's intuitive approach towards this.
Right.
This is where we thought and began to think. Okay, we can probably write some sort of software algorithm to let's say take what we know to as humans and algorithmically approach pricing to it. So that's
Right.
but then what we thought is, okay, how do we know that algorithm is actually correct? How do we know that the algorithm is actually, so it would need to have some sort of self monitoring feature to
Right.
check if it's doing okay. And then it would need to then look at, let's say, historical data and its own results to determine if it's accurate. So then
Right.
I actually, this is funny. I don't know if you know Lance Martin. He was one of our guests actually here many years ago. I remember he worked at Uber as a data scientist, but I'm sure there's many different people. But he told me that one time, what was the difference between data analytics and data science? And he said that data analytics is when you're using humans to make decisions about business decisions. And then he said data science was when machines are making decisions about, um, you know, I guess business decisions. So we got to this point where we realized it's probably better if we want to scale and we want to get, let's say, thousands of properties in our inventory, making thousands of revenue management adjustments to actually think about how a machine would actually start making these decisions rather than people. And then we would, as people, then just create new uh, algorithms or new models for the machine
Right.
to practice on. And ideally, the machine would figure out how to do this itself using its own learning process. So we think I'm not even sure how. Actually, this is a great question. How does Uber come up with the price for their? It's surge pricing, right? So it must be also done on an algorithm that's tuning to certain
It
data.
is, yeah, it's a ultimately it becomes an optimization problem, right? I mean, the objective function that you're trying to balance is your demand and supply should be balanced always.
Right, 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 right.
Ideal scenario will be what is the demand and what is the supply.
Got it.
So that's how like pricing. So, but this is one component of the pricing. Other component is definitely historical variations. Like you keep on looking what is the price that drivers are willing to pick and what other customers are willing to pay. Um, I don't have much details on the how exactly this pricing works because my focus has been always on the data side. Like how do I optimize data and um, there's a whole team of like called a marketplace, which essentially works on these pricing models.
Definitely. Okay, no worries. Over to Vidi. Vidi, maybe any questions on your side for Mr. Ritesh Agrawal?
So yeah, it's very interesting about your the view on the AI as being the last resort, and I completely agree with that. So in Bukit Vista, actually, one of the reasons why we're trying to build an AI on this is because again back to what Mr. Jing said, uh, a- even as revenue managers, they used to have different formulas to judge the price for a certain property. They have different calculators, they have different methods.
Right.
So there is no one specific method or rule to construct an algorithm with. That's why we thought with these huge amount of parameters that constantly may change, we thought that a neural net can validate and create a model fit to for that particular problem. And
I wasn't saying we shouldn't be using machine
oh yeah,
learning
yeah,
for
yeah,
it.
yeah,
What I'm saying is like the concern I have these days is it's like you have a hammer.
yes,
You can
yes,
just fix all the problems with that hammer. If you have to put a nail, you definitely use a hammer. But if you have to drill a hole, you just don't use a hammer, right?
yeah, yeah,
So,
yeah. That's
but the
true. That's
problem
true.
with I see with the industry right now is like okay, just people think just use machine learning and you can solve all the problems of the world. I mean, some problems doesn't need to have a machine.
Yeah, that's
The
true.
cost of there's a huge cost of maintaining a machine learning
Yep,
model, and there should be a good ROI. So in your case, I think the way Mr. Jing was explaining, I think it makes perfect sense because you have these dynamic pricing, right? And this is the core of your business. So you definitely want to have a model, but keep in mind you cannot just deploy the model because models can go there can be so many things that can actually make the model fail. For
yep,
example, there's a bad feature engineering,
yep,
the logging pipeline had some issues. So building a once you start deploying a model, you always also will have to think of building this ML platform where how do you update the model, and once you update, how do you validate the model it's working. So can you run two models in parallel and compare the results, or you have some kind of back testing. So there is a I mean companies end up actually maintaining like 10 or 15 engineers just to build these platform solutions for machine learning.
Interesting. It's almost like it's a very expensive pet to have.
yeah,
Yeah, it is. I mean, it it is necessary sometimes, and you can get away from building all these infrastructure.
Mhm.
But I mean, with the if he is working on CNN and all the thing, I would say realistically he will be spending 20% of his time on building the model,
Mhm.
and 80% of the time on doing feature engineering, figuring out how to deploy this model, how to hook up a real live and this is an online model, right? I mean, where you are looking at online demand and supply and trying to figure, so hooking up all those features, I mean, that will be huge. I mean, so
yeah.
expect your like 90% of the time to spend on these things, and really 10% on building the model itself.
Yep, yep, yep. That's very true, actually. So since I've been building this model, actually, I've spent a lot of my time doing pre-processing, looking up a lot of data sources, especially and how to find this data, and that's why it's quite interesting to see the construction of AI in non-academic field.
Yeah.
And actually, I have a question actually, Ritesh. So regarding the volume of data, I'm actually interested in knowing, like, when you have a machine learning model, for instance, and you have this huge amount of training data, there's always a new entry, right? You can simply update the model and kind of like, and you have two choice. You can update the model using the only the new records, and also retrain the model over the whole data set again. But for me, it doesn't make sense. How do you actually update a model?
Oh, yeah.
Ah,
That's a good question.
it's interesting. I mean, this is whole in new 90% of the time you just retrain the model.
Oh, I see.
Just
So yeah,
you don't just use the new updated data because there's this whole engineering cost. Oh, because now if you have to update the model, first you need to figure out from where the model is stored, download the model, read back all the data files. It's
Yep.
just sometimes easier to just retrain the model, and that's where retraining a model, it's completely a different new challenge. I mean,
Yes.
so
Yeah.
think about this. I mean, why the reason why complete retraining happens most of the time. I mean, and this depends. Things are definitely changing with neural networks because the cost of retraining is pretty high. So in neural networks, usually you might be updating the data, but in traditional ML modeling, you just retrain the whole thing because train it doesn't take too much time. The
Yep.
amount of engineering you have to do on updating the model might be high, but for neural network, yeah, they must be just updating the models with new records. And actually, that's what you want to do because otherwise, you're losing all the things that you have trained previously.
Yes.
Essentially,
Correct.
there's no transfer learning that is happening. The challenge is, yeah, I mean, you can do weights, right? I mean, one thing is, if you do that kind of thing, how much time will it take to pick up new patterns? How much weight do you have to put on the
Yeah.
new items? And that weight has to keep on increasing. So essentially, when you do retraining in a typical ML model, you say, I will use the last 3 months of data, right? And because you know you're using last 3 months of data, you can say, if I want to train heavily on my recent data, you can set appropriately weight. But if you're just updating your models with new records, what will it will take a huge amount of time to pick up the new patterns.
So and but like how do we decide, for example, in the initial training of a model, you have these numbers of epoch. I understand that it will the weights should converge to the minimum loss function, but when you try to update the model, you wouldn't have to kind of like, you don't want it to converge towards the new set of training data set, right? So I'm actually curious on how do we determine the iterations or the number of epochs from this training of new data?
And I mean, this is a completely different can of worms. I mean, um, ideally, you want to ideally, like a company like Uber, you will experiment all these different things, right?
Ah, I see.
You can say, oh, let me just try 100 epochs and see. Or you can have the usually what you do is you look at the stopping criteria, right? I mean, when should you stop training the model? um, and you usually stop if for last 5 epochs you haven't seen the model performance on validation data set has increased.
I see. So it's still a computational experiment.
No, I mean, so actually, I'm not sure. I mean, you talked about convergence, right? You're
Yes,
talking about
yes, yes.
convergence, right?
On the update on the new set of data set, training data to update the neural net.
Actually, I don't have much exposure. I mean, I haven't done worked on updating the CNN models, or like I haven't worked so much on AI myself to have to comment on exactly how to update. But it's you definitely increase my curiosity to now figure out what's exactly happening.
I see. Thank you very much. Yeah. So yeah, because yeah, I've been wondering like how do like big companies actually update their model. It's quite difficult to imagine you have to retrain a neural network model from the beginning, right? Because the
Now,
number of
uh,
parameters, epochs.
yeah, especially some of these models takes like days to train.
Yes,
So
correct, correct.
um, I mean, I'm thinking all these word to vec models that Google
Oh
provides.
yeah, yeah, yeah. Go
Uh,
to that.
so I'm sure you can find tons of paper on this topic. I think the biggest challenge is how do you weight your instances,
Yeah,
latest data instances, um, in order. The problem is like if you put these weights, you have to constantly increase. I don't know. Yeah, Um this is beyond like my expertise area.
yeah. Okay. Thank you very much, Ritesh.
Okay. Actually, that sort of borders a question that I was about to ask, and thank you very much for asking, Vidya, as well. Which was, I was going to ask how often is data being used to tune the algorithm? Um, but I think that sort of covers that line of thinking. We actually have kind of a debate inside this company, which is maybe this is a good time to sort of look at it. I noticed that most of the data that you're collecting, it's all internal data. It's all data that's coming from the app and from user engagements. How often does Uber use, let's say, external data to incorporate decisions about pricing or about like efficiency? How often do you borrow from, let's say, databases outside of the data being generated by internally?
um, I mean, I definitely know we use external data. For example, when we are building maps, definitely we are not building maps from ground zero. We are buying a lot of the data from a lot of other companies. For like marketplace optimization, I'm sure, I mean, I don't have any specific, but I'm sure they must be buying data from some other companies, which kind of gives them insight, like who are the competitors, what are their prices, or like how much they are charging. I'm sure, I mean, yeah, I've worked so much on the backend optimization that I really don't have a lot of insights and understanding on the product side.
Understood. Okay. No, that's perfectly understandable. There's definitely as an engineer, I know everyone always asks me to fix their computer, but I designed microchips. I designed microchips. I don't. Okay.
Yeah.
So okay. All right. That pretty much covers it. I actually noticed one thing. This is more of a professional networking question. Do you know Francisca Bell very well?
Oh yeah, I used to report to her.
Oh, okay. Because I watched her video on your, I think, LinkedIn, and what she was talking about on creating a forecasting platform is pretty much
Right.
what we want to do. So what we want to do is part of our business model is this. So traditionally, property management companies, there's sort of two flavors. There's one that work for, let's say, a commission, like Uber, like Airbnb. They sort of like take a certain cut, and then there's the other that work on more of a merchant model where they actually rent the property first, they furnish it whatever, and then they rent it out again to a guest. So we're definitely in the first category, but what we've noticed is that in order to be, let's say, strong in the first category, you have to be able to create a forecast at the beginning of a business deal, at the beginning of a business relationship, to say this is what you're going to make, and this is our confidence about how accurate it's going to be. So this is pretty much a project that Lilith and Video are working on and focusing on at the moment, which is basically how to take the data that we've accumulated over the past 7 years to predict on what property that we'd like to acquire will make.
Right.
So when I saw the video Francisca Bell made about that, I was like, yeah, that's kind of like that's it. Would there be a chance that we could get an introduction to Francisca, or
Uh,
would that be?
if you're really interested in time series modeling, um, so Fran, I mean, we call Fran.
Okay,
She might not be able to give you the details of the infrastructure, or I mean, are you interested more in the platform or in the algorithm itself?
probably the algorithm at this point. Well, Vidi, over to you. You're kind of
I think algorithms are right.
the algorithm.
Yeah, if you're interested in algorithm, then Slavic is the right person to actually talk to.
Slavic, yeah.
So, yeah, Slavic. He is the winner of M3 competition, and so he was the main brain behind like building the. He was the core person to build all these time series algorithms.
Did you say time series algorithm?
Yeah, time series. So essentially, you have these. So it's interesting with time series also. Like nowadays, people are using RNN for time series predictions.
Huh?
So the good thing with RNN is you can take all the historical data as well as some other data points like is it a holiday, is it what kind of a tourist season, and all those kind of information.
Okay, got it. Okay, Slavic. I'll reach out to him. Does Slavic have a last name?
Oh, always forget his last name. Wait, let me. I think it starts with smile. S. Yeah. Uh, it's Slawek and last name Smyl.
SMIL. Smile.
Yeah, smile.
Okay, and winner of an M3 competition. Okay, interesting. Fantastic. Okay.
I can paste it.
Thank you, sir. Thank you. Appreciate that. Let's see. That's pretty much it from my side. Let's go back to Lewis. Lewis, any further questions at this moment?
Uh, yeah, actually, because I'm not really that deep on the data infrastructure and something like PD because I'm not from computer science. But from my side, because I'm an industrial engineering, maybe related to that customer behavior, just like that, but using data, maybe what's Mr. Jing asked just now, it's related to how we can use data to understand our customer our customer behaviors or like yeah something like that. For example, like Uber, when how you create an app or a product that it's fit for customer, but basically using data, just like that. Do you have something in mind about how to create a good product for our customers, but using data driven decisions, just like that?
It's interesting. I mean, and first of all, you don't have to be computer scientist to be a data analyst. I mean, I'm coming from geography background myself, it's a. I think all you need is a curiosity to be a good data analyst. For product, I mean, what you're asking is a very tough question. Is like, what is um, what increases customer engagement? And typically, it's very difficult, and that's why companies actually just do A/B testing. So, should we have like, let's say, red color button or blue color button? You don't know, you cannot tell really what is a better way. So usually you will say, okay, let's do a AB experiment and let's see where people are able to click more. So if I think the good, as a data analyst, the value you can bring is more in helping the product team to how to validate certain hypotheses and experiment it, and also asking the right questions. It's very difficult to really get if you have these such open-ended questions. It's very difficult to really say what exactly is the most important driving factor,
Mm,
because there will be so many correlated variables. So I would say, yeah. I mean, don't have a very broad, open-ended questions. Try to have a very well-defined questions and just address that.
Cool.
yes, sir. Yeah, because why I asked that, because we are using Airbnb as our platform, right? So we don't have like a really a direct access to how people reach our listing, let's say, because we list our property in a single listing, right? But Airbnb has that. It's like how many clicks or something else. Yeah, we have some data of that, but can exactly understand the journey that the guest had, just like that. So thank you very much for
Um,
your suggestion about that.
One thing always keep in mind, uh, ML, AI, data science, these are not like magic wand that can just give you any answer. They, unless you have a data, um, only if you have data, then you can hope to get answers. But also that is double-edged sword, because there can be biases in your data, the way you have collected data, and that itself can introduce so much bias in your understanding. So let's say you're able to get some data from Airbnb, but Airbnb is giving, let's say, only data for all the kinds who visited in at a particular hour of the day. Then your understanding is only for that particular hour of the day. You cannot say, oh, this is my complete view of the world. So it's a very, I think, always trust your hunches, always trust your gut feeling. Don't just uh, it's good to have an open mind, and but don't ignore your gut feelings.
I've experienced that. Oh, if I may, I've experienced that a few times myself. Our CTO was pretty much in charge of creating the data visualization for years, and the thing that you just mentioned, Mr. Ritesh, about time zones was something that I saw so many times. Like we would be recording a booking happened today, but actually it happened another time, and
Right.
just by shifting that, like the truth depends on really the perspective. I've realized if you take a different time zone, the truth looks different. And the other one was currency exchange values. So we would look at, let's say, how much money we made. We thought that was a fixed number, but that also changes because we accept currencies from different people at different times. So yeah, yeah, I completely hear that.
Yeah, that's why we at Uber we keep all the data both in local time and UTC time.
Mhm.
And as you're right, currency is another more tricky thing, and that's why we also keep data in local currency and USDs.
Definitely, definitely,
So because otherwise these are constantly changing factor, you cannot really go back and look at historical conversion rates for each record.
definitely. Okay. Perfect. Let's go to Vidi. Vidi, any final thoughts before we conclude?
Um, I guess for now, not yet. But thank you very much, Mr. Ritesh, for the discussion. It was very interesting.
Okay.
Okay, yeah. Good luck. I really enjoyed. Next time if I'm in Bali, I will definitely reach out to you guys.
Definitely.
Thank you very much.
And like I said in the beginning, we'll be very happy to host you. Let us know when you're coming, and we'll look after you as friends and family. Yeah. Uh,
Yeah, sure.
okay. And
Okay, good luck, guys.
just out of curiosity, would you be keen to widen your audience for your articles or knowledge in Indonesia by any chance?
What do you mean?
Well,
Widening?
I was thinking like Vidi, perhaps maybe your professors at UGM might want to have Mr. Ritesh speak. I don't know in the future or such like that. I've been a speaker before at Vidi's school, and it's a very decent school here that produces I think really good candidates, and also Lilis's school happens to be like the MIT of Indonesia too as well. If you want, I think I've noticed that you regularly publish your articles. Would you be interested in being like involved in guest speakers or whatever at the university level?
Sure. I mean, I enjoy educating. I mean, telling people what I know.
Okay.
Definitely, I don't know everything, but I enjoy like whatever I have learned and experienced and talk about it. I mean, there's always everyone has so many interesting things to share about and to learn from each other,
Mhm.
and I always learn those kind of enjoy sharing what I'm learning these days.
And I'm sure we here have totally enjoyed actually learning the principles behind data science infrastructure with you today as well.
Yeah, I mean it's fun. I mean, for example, I have my own biases. I mean, I always thought like the question you asked, like, should there be a separate analytics? I would have said yes, but now when I think about like a small company, when there's I don't think it's necessary to have a separate analytics engine because it's not worth the cost. Right.
Correct. Okay. Well, thank you for well coming with us on that journey then
Yeah.
and seeing what that looks like. That's pretty much it, Mr. Ritesh. One of us will write a thank you letter on LinkedIn and we'll post it and just acknowledge you for sharing your time and expertise with us. And we hope that you'll take that as an act of gratitude. Oh, but one thing I need for that is I need a screenshot real quick. So if I may, I'll take a quick screenshot of everybody, and we'll give Mr. Ritesh a thumbs up, and we'll post on our LinkedIn. Okay, ready? 1, 2, and 3. Okay, done. Okay. So, wow, thank you very. What's everything like in the Bay Area now? I'll stop recording at this point.